Welcome. My name's Jeff McGee. I have the privilege to be the chair of the BCS Academy, and I'd like to welcome you to this, the 2015 BCS Lovelace Lecture. The Lovelace Medal was established by the BCS in 1998, and the medal is presented to individuals who have made a contribution which is of major significance in the advancement of information systems, or which adds significantly to the understanding of information systems. It is given in memory and honour of the great Ada Lovelace, a mathematician and scientist who worked along with Charles Babbage, the computing pioneer. So Karen Spark-Jones, Sir Tim Berners-Lee and Linus Torvalds are among the distinguished computing scientists and engineers that have previously been awarded this, the Lovelace Medal. Joining this illustrious list of names tonight is Steve Ferber, who has been awarded the 2014 Lovelace Medal. Steve Ferber, CBE, FRS, FREng, is ICL Professor of Computer Engineering in the School of Computing Science at Manchester. After completing a BA in Mathematics and a PhD in Aerodynamics at Cambridge, he spent the 1980s at Acorn Computers, where he was a principal designer of the BBC Micro and ARM 32-bit RISC microprocessor. Steve moved to the chair at Manchester in 1990, where he leads research into asynchronous and low-powered systems, and more recently, neural systems engineering. The Spinnaker project is delivering a computer incorporating a million ARM processors optimized for brain modeling applications. I'm delighted that the BCS is able to recognize the outstanding and sustained contribution Steve has made over his career. So Steve, can I ask you to join me on the stage to receive the BCS Lovelace Medal? So normally, at this point in the proceedings, we would ask Steve to give the lecture, but this is a little bit, this year, like This Is Your Life. So we've got a number of videos and speakers before the main event.
So the time I'm going to refer to is 1978, 79, 80, 81, 83. And it's such a long time ago that when I started reflecting on it, I remembered that Romans were running around the place, and that's why I couldn't remember anything. But Steve was a member of that Cambridge processor group, Cambridge kind of student society, even though he was doing turbo machinery about blazing turbines and flows and getting them very close. So what is this guy who's in the analog world doing with computing? Well, the man was quite brilliant, and it was quite clear, so he joined the nascent Acorn company as a consultant and started working on some projects. This is before the BBC Micro, when the company was, very, very small. And I think he worked on some lead thing, which I couldn't quite remember, but he certainly worked on electronic fruit machines, ka-ching, at that time. However, moving forward, he was very much, part of the fold and very active computer engineer. And Acorn designed one machine, another machine, a third machine, and then the third machine being the BBC Micro. And that BBC Micro had chips in it. That was one of the things, bespoke chips, that made it interesting. So if I can share one or two anecdotes about those chips that popped into my head, because Steve was the designer of the architecture, a group which included some people from the university, implemented the layouts and so on. And the CAD system, which was a consequence of an earlier project, was being used by Acorn in that symbiotic way that existed between universities and industry at that time. And it was quite a fancy CAD system. You could describe the circuit, you could automatically lay it out, you could back annotate things from that layout, you could put it into a bigger simulation as part of a systems architecture simulation, and you hope it would work. And his design and that implementation, we prototyped it, worked, we put it into a ceramic package for the testing, and everything, but it was happy. And this was the video processor, the thing that controls the pixels on the screen. So the company orders, I forget now, Steve, 10,000 or some volume of these chips for manufacture, and they arrive and they come packaged in plastic. And we switch these machines on, which are due to go to customers, and after about 10 minutes, the screen starts disappearing, right? And there are no pixels of any kind, right? Where the pixels go. So it's a little tricky to sell a computer that doesn't show anything on the screen. There wasn't an internet thing at that time, it was games. And now the reason was that the tight design that was required on those very few gates that were available on this Ferranti gate array required a daisy chain of clock amplifiers, which then passed their timing to the appropriate bit of the circuit. And the CAD system hadn't picked up that there was an asynchrony between the rising and the falling edge, and as the thing heated up, the rising edge caught up on the falling edge, and fairly quickly the clock disappeared. Now the ceramic package had better thermal properties, so it didn't happen, whereas the plastic package let it happen, and none of these chips worked. So we almost went bust on that one right there and then. And it was not quite all his fault, but it would have been, no doubt, if it had been. So there we go. When the ARM was to be made, we then bought professional grade, very expensive software, which as far as I was concerned was not better, it just had a better user interface and perhaps a little more support. Now, actually wooing Steve into the company was not completely straightforward. He had his PhD, he had an RA position, he was a consultant, and we used many techniques, and one of them was food. So free food in the local restaurant of choice was always available, essentially every night. It would, not just Steve, but others. He just took longer. More spaghetti or whatever it was. But actually, on occasions like that, I remember him contributing and making all kinds of designs on the back of a napkin, and actually some of them were quite brilliant and were used in practice. So it's not a bad method. Another thing I remember from those days is that one of the things that was visualized very well on the BBC Micro was your house in Linton. And I know Valerie is here, his wife, and we could see this house from above and this way, that way, and so on. And we were most impressed, and it was a lovely house. And there was quite an overdose of it. Anyway, we were having fun. And then the ARM came along, and the design, there's a whole story about why that happened, which essentially involves technology transfer from the US and spotting it and then having the confidence to go gangbusters on it. But of course it requires some extraordinary design skills as well. And so it has proven that not having much money and not having many gates and having a small team can produce rather brilliant results led by Steve. Again, there are one or two anecdotes. So for example, I remember the fast interrupt request coming along after I think perhaps you consulted another brilliant designer, David Wheeler, who was one of the pioneers of the original computer EDSAC, and suggested that you might have that. Then there were the conditional flags on the instructions, which is a kind of a sophism, I think my memory recalls well. So there were some absolutely amazing features of the architecture, which obviously have stood the test of time. But it's when I look back on it, the team was yay big. I mean, it was a cuddly, friendly, small team, and the money would go around buying everybody dinner every evening because it was just a magnificent situation. And in the cluster, in the bigger picture, whether with the university or other companies, or Ferranti or supplier or whatever, you know, there was support and enthusiasm for this weird thing doing a risk. You know, there was Intel around then, and you'd be mad. And there's Intel around now, and maybe they say you're mad. But there we go. I look at the CEO of ARM. Now, and clearly it's not. So to finish off my little bit, Manchester were lucky enough to grab him in 1990. I would have much preferred it. I'm sorry, Carol. If he had stayed with us in Cambridge and Cambridge University, but we had the really bad fortune then to lose him. But he has been doing an absolutely amazing job there. We'll hear about some of that later. So I hope you enjoyed some of those anecdotes, and if we have a chance afterwards, there are even some more eccentric ones if you tempt him or me or somebody from that time. Thank you very much.
So I'd now like to ask Simon Seegers, Chief Executive from ARM, to say a few words about Steve. Simon.
Thank you, and good evening, everyone. It's a real pleasure for me to be here tonight. My first real experience of using a computer was learning to program a BBC Micro. One of the things I thought was really great about it was you could physically take it apart, or at least I could, put it back together again, and it still worked. And that was not the case for many things I took apart when I was that kind of age, but the BBC Micro certainly had a robustness to it, and I think I learned from an early stage there something about engineering and creating a solution that was going to be robust and stand the test of time. Now, my interaction with Steve came about when I joined ARM. As Andy mentioned, the technology was developed within Acorn and then spun out into a company. And the company was formed in this turkey barn in the middle of the Cambridgeshire countryside, as shown on the left there. And that the technology came out of Acorn with an idea that the fact it was small and the fact it was low power meant it could be put inside a chip by somebody else with a whole load of other features put around it and turned into something kind of bespoke for some application that maybe we wouldn't know what that was. So that was the raw idea behind the creation of ARM, the company. And there were 13 engineers that were spun out of Acorn. They hired a CEO. First time I met him, I thought he was crazy to have this idea to take this technology and license it to other companies who would then build these chips and then collect a really small royalty off of every chip that got sold. Sounded like a crazy idea, but at the time I was really interested in designing a microprocessor, and living in the UK, this was like the only place I could go to do that. So I moved to Cambridge a couple of months after ARM got founded, and luckily for me that turned out to be a really, really good career move. You can see the original chip here on the right. By today's standards, really quite small, 25,000 gates, and built on a 3 micron process running at just over 6 megahertz. Times have moved on a little way. And what's turned out to be really useful, and we thought it would be at the time, but nobody could really know quite how useful it would be, was that these attributes of being small and low power meant you could use it in all these different end applications. And that has certainly led to a scale that really nobody did anticipate. If we look at the volumes of ARM processors shipped today, all of which are based on the inventions that Steve and his team created back in Acorn, the numbers are truly staggering. Last year alone, our licensees sold 12 billion chips containing this technology. The cumulative volume is now over 64 billion chips. And as you saw from the little video clip, your mobile phone has probably got one in. It's probably got about 4 in. Actually, we're very well known for the technology being used in mobile. But the technology is used in many, many other places. And it would be really quite surprising if your journey here tonight did not involve interaction with a number of ARM microprocessors. When we look at the usage, when we break down these 12 billion chips, they're going into all sorts of end applications. Your washing machine, your car, your DVD player may well have an ARM microprocessor in it. And of course, your mobile phone. I usually present to audiences where everybody has a smartphone, and I'm pretty sure I'm on safe ground here tonight. You've all got an ARM microprocessor in your pocket based on Steve's work. So in mobile, just the pace of innovation has been truly phenomenal. That really small, really power-efficient microprocessor, over the years we've morphed this. Some of those features, which were really elegant that Andy mentioned, actually turned out to be quite painful when you're trying to produce a processor that runs a couple of gigahertz. But we've kept to the true spirit of the processor and delivered more and more performance over the years, but maintained this very power-efficient design. And that really has been key to many of the applications where ARM is used today. You heard the story about learning firsthand the benefits of low power, so the chips don't melt. Well, it is quite amazing that over the years we've been able to increase the performance of these processors and still have them run off very small batteries. In just the last 5 years, the processor performance has gone up by 17x. The battery technology that's in smartphones has only roughly doubled in efficiency in that time frame. At the same time, the screens have got bigger, the memories got bigger, the modems got more sophisticated. The emphasis on low power design, whose roots stem back to that ARM processor, has enabled that to happen. And this goes on. We recently launched a new product. We now have these unintelligible product names that we put on these ARM cores. And with every generation, we're trying to drive more and more efficiency, both in the processor and in the computing system it's designed into. We now mix and match processors of different sizes, different capabilities to enable the efficiency of this really complex software that your smartphone runs. Now, we're best known for the use of ARM technology in mobile phones, but it isn't just there. If you look what's happening in cars right now, cars are becoming supercomputers on wheels. The amount of processing technology in a high-end car is phenomenal. There's about 150 processors in a modern high-end car right now, and they're being used for many different features, providing a better driving experience, but also providing a safer experience and a more efficient car. So efficient processing technology being used to make something like a car more efficient and, of course, safer. And that is ultimately going to lead to the connected car, where hopefully we don't have to drive at all and can get all this leisure time that technology has always promised, but is never seemingly quite delivered to us. So it's really quite phenomenal where this technology has ended up, the way in which our customers have found uses for this invention that no one was thinking about connected cars, I assume, back in the early 1980s. Nobody was thinking of quite where the technology would end up. And at ARM, one of the fun things about this job and this business is you get to talk to people who are doing all of this crazy invention. And one I thought I'd share with you, which leads on to a theme for today, is one of my colleagues, our CTO, who's one of the founding team, worked with Steve in Acorn, a guy called Mike Muller, likes to look at these kind of crazy projects, and he came across this, and I apologise, it's a bit hard to see, but it's actually a toaster. Now, why would you want a microprocessor and a toaster? This was some work that was being done at Brunel back in 2001, when something like this might be called a web appliance, and they thought, oh, what should we do with this? We'll hook it up to the internet, and we'll use it to create something that's going to tell you what the weather is like in the morning. Put some bread in, goes off to the internet, gets weather forecast, and prints either sun or cloud. Now, 2001, that was a radical idea. So that was a web appliance, and now we're contemplating microprocessors going into all different things that you might not necessarily expect a microprocessor to be in. And nowadays, somebody coined the term the Internet of Things, inert objects or seemingly inert objects connected to the internet, gathering data, and then through analysing that data, being able to find better and more efficient ways to use basically the Earth's resources. So this is a big trend, and anyone you talk to will give you a different enormous projection for how many connected devices there will be. I don't know what the right answer is, but I know it's going to be a lot. And this as a technology trend is going to be one of the ways in which I think society deals with the growing pains of a bigger population, an older population, one which lives in very condensed cities. Because as I look across these challenges of whether it's producing food, shipping it from where it was produced to where it's going to get consumed, dealing with mega cities with all these people in, dealing with healthcare as we all get older and deal with chronic illnesses, technology has a role to play. We will see billions of processors, tens of billions of processors solving these kind of problems, all of which need these attributes of really small, really low power. And that was embedded into the basic design of the ARM processor that took place in the 80s. It's been a real pleasure for me to have been involved in developing this technology and seeing it used in all these different ways. Over the years in ARM, I got to meet Stephen. It's been a real pleasure getting to know him. In my copious spare time, I decided I'd like to do a master's degree, and Steve fortunately agreed to be my master's supervisor, and we'd send emails to each other and tell me what I was doing wrong. And after a couple of years, I eventually qualified without ever actually physically going to Manchester University during that time. But it was great. I appreciate the effort that you put into that. So now I find myself as the CEO of this company. From those humble beginnings back in the turkey barn, it's a real honour for me to now be leading the company that is commercialising this technology that Steve invented. It's been a pleasure to get to know you over the years, Steve, and I'm really interested to see what's going to come next out of your lab. So enough of me. I think it's time to hand over to Steve.